Hello, everyone. My name is Denis Harasmuk, and I'm very glad to present my course project for NYU Java course. Here you can see the main GitHub repository of the project. It's README, and here is a link on documentation in Notion. First, I want to start from the documentation in Notion, and the first part is project aim. In this project, I have developed a web banking application based on a microservice architecture. The system has the next functionality: user registration, user login, send money from one card to another, top up user card balance, list user transactions on the main page. Since I already had a similar project, so I describe this here and put some links on them on front end and back end. So from that project, I reuse front end, and as the main project aim, I am in this course project. I want to create a backend for this UI. Here you can see features for the project, this functionality which I already presented, technologies. I use Kafka and Java 8, frameworks and libraries, Spring Boot, Kafka for Spring, Kafka Streams, Spring Data Cassandra, Spring Data Mongo, OS Java SDK, and so on. These are the main libraries. Another part is databases. So I use OSK Spaces, just serverless Cassandra, Cloud MongoDB, and OS 3, this blob storage. And here is Java features. The first one is microservice development, REST API development, integration with Kafka, just event-driven design, interaction with two NoSQL databases, logic with GVT tokens for authorization. Next part is detailed design documentation. So let's look at the high-level architecture of the project. So firstly, user go to our website, and as response, he gets React web app, which is running in his browser. When user makes some interaction with the system, requests are sent to these three REST microservices: this auth service, orchestrator service, and account service. So auth service have connection to MongoDB collection just to save user information and create a GVT token. And it also has access to Cassandra database just to save assigned card to it. Another service is orchestrator. So it is responsible for transaction logic. When user makes any type of transaction, it's processed by orchestrator. It creates special message and send it to a topic for transaction service, and transaction service read it and make some special logic between transaction service and card service, what I will describe in several minutes. And the transaction service and the card service have access to Cassandra database. The next service is account service. It's mainly responsible for account management operations, and it has access to OS3, like not OS3, but Cassandra, and to MongoDB collection. And I want to fix my previous question, since orchestrator don't have access to Cassandra. It has access just to OS3. Access to Cassandra, card service, and the transaction service. So the next diagram is interaction of microservices. So here you can see events from the UI and what logic they trigger when they execute it. So the first page is the registration page, and when the user click submit button, request is sent on the registration endpoint to our service. And our service starts this process of assigning card. It uses card manager, and card manager class use cards table in Cassandra. And if registration is successful, user is redirected to login page. When user input his credentials, request is sent to login endpoint again in our service, and our service check username and password and create GVT token based on information in MongoDB and return the GVT token. Just set it to cookies in the user browser. Another page is profile page. So when user go to this page, there's some bunch of requests are made. So the first one to get balance, get transactions, and get notifications. So for these two endpoints, account service have access to Cassandra, and for get notifications and handle transactions, the orchestrator service have access to Kafka and ABA SS3. And account service and orchestrator service, of course, have access to MongoDB to check GVT token. So each REST microservice can validate GVT token, so it simplify logic and make it faster. And here I describe it in more details. And the next diagram is transaction logic. So when user make transaction, any type of transaction, it is processed by orchestrator. Orchestrator creates special message and sends it to the topic for transaction service. So when transaction gets this message, it creates a new record in transaction table with status new. After it creates some special message for card service and send it to appropriate topic for it. Card service read it, look at event, so it's just the first initial event from transaction service. It processes it, looks if the user has enough credit limit, just enough money on his card, and if yes, so it reserve this money and send that reservation is successful to transaction service. Transaction service like look if it is a success. So yes, we can continue. It change status from new to pending, and send a new message for card service for the same transactions that it is finished converting status to pending, and it is processed by card service, which now can execute transactions. So it's just decrease amount of money from sender card and increase amount of money in receiver's card. And after, if all is fine, all is okay, successful or failed status can be returned via Kafka to transaction status, which change status from pending to completed or failed, and send status of the transaction to result topic, and orchestrator reads these messages and save transaction statuses to ABSS3. So like as I mentioned previously, orchestrator save status transactions in ABSS3, and to get some notifications to get that transactions are processed during the active session of the user, when user go to browser and now it gives some transactions. So it's called notification in my system, and orchestrator just it is pulled every 10 seconds, and it's go to OSS3 and go through special folder structure and fastly get status of the transaction if it is of course processed. I needed to create such logic, so since I used Kafka, and as we know, interaction with Kafka is asynchronous, so I needed somehow to display status of the transactions. And yes, another important point about this logic with card service and transaction service is just reservation. So in general, such money reservation helps to keep money in a pending state until another payment system will start to process them. So it can be pretty useful. And another feature is that this reserved money can be canceled in case of failures or user decision change. And another point about transaction card services that they don't have derivative validations. In the only way to communicate with them is through Kafka topics, which must be protected in production. So it's pretty logical. In the next part, I describe my design decisions related to software applications, to data storage, and yes, I will stand with Ukraine. And another part which I wanted to present is README. Here I tried to briefly describe my project, short summary, link on the Notion documentation, port to a microservice table, and also some links which you can use to check Swagger documentation when you will run my project locally. Features which I already presented in Notion page and diagrams, pretty the same. And here may be the main part of the README, how to run the project. So I will start it now. First of all, of course, you need to download Kafka. I already installed it, so I can just directly copy this comments and run. Firstly, I need to run Zookeeper. It's like orchestrator for Kafka servers. And after I need to run just one Kafka server. So starting, yeah, and now it's ready. So as the next part, you need to create appropriate topics. I have already created them, so we'll skip this step. And the next step, I need just to run all my 5 microservices. I show how to do it from the console, but of course you can run them from your IDE. So I'll start, or I started OS, start orchestrator, start transaction service. So it's pretty simple logic, just bash run services hash, and I hide this logic how to start each microservice behind this file. So 1, 2, 3, 4, 5. Starting, okay, it started. Transaction service started. Card service is starting. Count service is started. And card service also started. So now I can start my React UI that I just type npm start. And it starts React UI. So previously I already tested my this UI, so I can just clear it. So I can exit, and yeah, now I can exit from my tested account and start from the beginning from this login page. So here I have recorded username and password for just develop and debugging purpose, just not to type each time. And I can sign in to my profile and get balance of the card, my username, card number, currency. I can make a new money transfer, top up balance, and of course I can exit. And here you can see a table of processed transactions with date, counterparty and destination, amount, and status. And of course, you can load more and get some previous transactions. So to test fully my functionality, I just copy my link on the React web and open it in the new window. So here you can see that I was redirected to login page since GBT token is not saved in cookies for this window. So let's sign up and let's create a new account. Username can be John Doe, and let's do it such a way. Okay, and password once again. For example, if I will fail password, so now I can enter my username. Yeah, so now I am logged in with a new account. So just my username, card number, balance, it's the same as for previous account. Here we also assign some amount of money just for testing purpose. So let's firstly try to make a new money transfer. So you can just copy card number and make a transaction and type any number, amount that you have. So you make just transfer for that card. So now it's processing, and just in 3 seconds, I can get output, can get transaction results. So here we get transaction results. Balance now is correct, correct amount, that was successful, correct card, today's date. And here we also can see that we got this this money from this card and this trade. So card is correct, 80, 20, 80, 20, 12, yeah. So now we can just check top-up balance functionality. We can increase our balance in any amount of money. We just created such functionality since this is not a real bank and we need to populate our cards and somehow to test our functionality. So it can be pretty useful. So yeah, now balance is correct and we get a successful transaction. And you can notice here that I didn't reload it my page, so React just do it instead of me, and I get correct result. And of course I can exit, and now it is exited. And let's go to my README. So yeah, just know that we have some expiration for GBT tokens, and in 20 minutes it will be expired, so you'll need to log in. And yes, also you can check some Postman, my API with Postman. So I have here some already created requests, which I placed in docs folder in my repo. So here they are, here is collections, you can use them, just import to your Postman and check API. And of course, you can check Swagger documentation for REST microservices. So this is for OAuth version 1. And here we have 2 endpoints, some brief description, more wide description, example of request body, responses return, and for another endpoint, this is the same. And here is some schemas for requests. And let's go to this README. So thank you for your time, and stand with Ukraine.